Formula Student is an annual competition run by the IMechE, where university teams across the UK and Europe compete to build a single-seater race car. The cars then take part in a number of static and dynamic events held in the summer at Silverstone Racetrack. It's a great showcase of design and engineering, and many techniques are utilised to turn concepts into reality. The content in this first series focuses on the design and validation processes required to create a Formula Student rolling chassis using SOLIDWORKS CAD and simulation. A rolling chassis is the backbone of any vehicle and contains the tubular space frame structure, suspension and steering systems. All other systems such as powertrain, drivetrain and electronics depend on a robust rolling chassis to exist first. An optimized race car considers the integration of all of these systems as part of the design process by taking a holistic approach to it. SOLIDWORKS offers an all-inclusive CAD package to build and test a complete model in the virtual environment. Everything from the top-level assembly down to individual subsystems and components can be created in one place with all the supporting information required for manufacture. This includes electrical routing and piping, costing calculations, detailed technical drawings with bill of materials, CAM machining instructions, reference documentation, marketing visuals and animations, and much more. However, the focus of this series will be the integrated weldment modelling environment and the simulation tools, specifically finite element analysis, rigid body motion and advanced topology optimization. This series is split into 5 parts as follows. In part 1, we will cover the 3D sketch and general layout of the chassis. Part 2 will cover creating custom weldment profiles and building the frame structure. Part 3 will consist of simulating the torsional performance in a static analysis. Part 4 will introduce the rigid body motion analysis in the suspension system to understand its behaviour under operation. And finally, Part 5 will consist of optimizing the topology of a key suspension component from an initial reference body. Let's take a closer look.